Let us evaluate this double integral x square by y square dx dy over the region enclosed by x is equal to 2, y is equal to x, and xy is equal to 1. So that means we have to evaluate the value of this double integral over this region enclosed by the line x is equal to 2, y is equal to x, and xy is equal to 1. So as usual, what we have to do is now you draw the graph of this one. X is equal to 2, x is equal to 2. So on the y-axis, if you mark this point here as 2, then x is equal to 2 will be a straight line which passes through x is equal to. So this is x is equal to 2. And then draw the line y is equal to x. Now y is equal to x, you construct a table. So you can see from here when x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 1. When x is equal to y is equal to 2. So it will be this straight line. So this is y is equal to 2. And then the next one is draw the graph of the third one. Xy is equal to 1. Xy is equal to 1 can be written as y is, you can express y in terms of x, so as 1 by x. So let us plot this point. When x is equal to 1, y becomes 1. So it will be this point. When x is equal to 2, y becomes half. And when x is equal to 1 by 2, you can see that y will become 2. So x is equal to half, it will be this point here, so it will be 2. So in this case, you'll see that it will be a curve like this, which come closer and closer to both the x-axis and the y-axis, but never touch this two axes. So now here what we need to find is the value of this double integral over this region enclosed by this line. X is equal to 2, y is equal to, this is y is equal to x. And then this is that one, y is equal to 1 by x. So that means this will be the region. The region of integration will be this shaded region. So now from this figure, you can see that the value E here denote that region enclosed by x is equal to 2, y is equal to x, and xy is equal to 1. So what will be the value of this double integral? Now you can see from here that the point of intersection of y is equal to x and y is equal to y is equal to x and y is equal to 1 by x is at x is equal to 1. You can see this common point. So what you need to do now, you draw the line which passes through x is equal to 1. So this is x is equal to 1. So let us find out now the limit of integration. For x, when you find out the limit of integration, you have to take from left to right. And for y, it will be from, you see what below it is bounded by which curve and above it is bounded by which curve. So from this figure, you can see that this curve, this enclosed region here or shaded region here is bounded by the line x is equal to 1 to x is equal to 2. So the limit of integration for x will be from x is equal to 1 to x is equal to 2. And for y, you can find out what is this shaded region here is bounded below by which curve, by y is equal to 1 by x. So the limit of integration for y, the lower limit will be 1 by x, and above it is bounded by this line which is represented by y is equal to x. So 2 y is equal to 1 by x. So this is equal to integral x is equal to 1 to x is equal to 2, y is equal to 1 by x to y is equal to x, then x square by y square dx dy. And the value of this one is equal to what? Now from here you notice that the limit of integration for x is in terms of constant, but for y is in terms of x. Please correct this one, it is x. So now here what we need to do now is, if the limit of integration for x is in terms of constant, then we can integrate that one afterwards. But first we need to integrate with respect to y. So here it will be integral 1 to 2. Then x square dx is independent of that one. That's not dependent on y. So you can take it outside. And then here it will be dy by y square. Integral from 1 by x to x. So on integrating this one, you'll get integral 1 to 2 x square dx will be there. And what is the integral of 1 by y square? Will be minus 1 by y. Then from 1 by x to x. Then this is called to integral 1 to 2 x square. Then it will be minus now. Okay, I can take out this minus sign outside. So 1 by y. The lower upper limit is this one. It will be 1 by x. Replace y by x minus 1 by x. And then this x will come to the numerator. So it will be 1 by x minus x dx. So now this one reduces to simple integral in terms of x, which can be easily integrated. And the proof of this one, the answer of this one has been given in the notes that will in the note, so you can just check that one how we complete this one, because this is just a simple integral. The main thing here is this one, how to find out the limit of integration and with what variable we need to integrate first, whether with respect to x or with respect to y. So you, from this particular example, we can see from here that since the limit of integration for x is in terms of constant and for y in terms of x, so always we have to integrate with respect to y first, so that after substituting the limit of integration for y, it will be in terms of x, so it reduces to the single variable only in terms of x, and then you can integrate with respect to x and substitute the limit of integration for x from 1 to 2. Now let us come to the next problem, that is this one. Evaluate this double integral double integral 4x square minus y square dx dy over the triangle formed by y is equal to 0, x is equal to 1 and y is equal to x. So as usual, you draw the graph of this one. Y is equal to 0 is nothing but is the y axis, x axis. X is equal to 1, it will be this line which passes through x equal to 1. So this is x is equal to 1, and then y is equal to x. Y is equal to x, you plot this point, then you'll see that it will be a straight line like this which passes through the origin. This is y is equal to x. So that means this will be the region of integration. And you can see from here that this shaded region here is bounded on the left side by what? Because the y-axis, so it will be x is equal to 0, and to the right it is bounded by x is equal to 1. So the limit of integration for x will be from 0 to x is equal to 1, and for y you can see that this shaded region here is bounded below by y is equal to 0, so the lower limit will be y is equal to 0, and above it is bounded by this line y is equal to x, so to y is equal to x. Again here, since the limit of integration for x is in terms of constant and one of the limit of integration for y is in terms of x, so we need to integrate this double integral first with respect to y and then later with respect to x. So double integral square root of 4x square minus y square dx dy is equal to integral x is equal to 0 to x is equal to 1, then integral this one y is equal to 0 to y is equal to x square root of 4x square minus y square dx or dy, then dx. Okay, because we need to integrate first this one with respect to y, and this is of the form, say, a square minus y square, where a here is equal to 2x square. So consider x as a constant, so we have to use the standard integral of square root of a square minus y square, which is actually integral 0 to 1. Then it is y by, or it will be y into square root of 4x square minus y square by 2 plus 4x square by 2 sine inverse of y by x. So from 0 to x, then dx. So you can see here that using the standard integral of this one, it is equal to that one. It will be y into square root of a square minus y square by 2 plus a square by 2 sine inverse of x by a, or y by a. So by applying that standard integral, we are getting the integral of this one by considering x here as a constant. So you substitute the limit of integration. Now wherever y is there, you replace it by x and 0 for the lower limit. Then you'll see that this equation here will reduce to a function of single variable only, that is in terms of x, and then which can be easily integrated. So the completion of this integration from 0 to 1 dx has been given in the note, so you can check it from there, that what will be the final value of this one. The answer is 3 root 3 plus 2 pi by 18. So the main thing here is you have to be clear with this one regarding the limit of integration. Find out the limit of integration. Always remember that when the limit of integration for x is in terms of constant and for y is in terms of x, so remember that you have to integrate first with respect to y, keeping x as a constant, and then substitute the limit of integration, and lastly you need to integrate with respect to x. However, there are some problems where the limit of integration for x is in terms of y and for y in terms of x. Then in that case, you need to integrate and for y is in terms of constant. Then in that case, you need to integrate first with respect to x and then later with respect to y. So I hope, because the detail of these two problems will be given in the will be sent to you. So you go through it and just see that how we are getting the limit of integration, how we integrate this double integral, why we integrate it with respect to y, and then how we find out the limit of integration. If it is not clear, you please let me know.